Okay, how did you do? Hopefully you're not yelling at me across the internet. I'm sure you girls and guys did just fine though. I'll show you what I did just in case you were having problems. Literally, I took the Blink program and copied and pasted the snot out of it. First, you need to set all of the pins you're going to use as outputs, right? So you can see here, I set up all of the pins 8 through 13 as outputs. If you don't do that, you're going to have a bad time. I then turned on just one LED to start off with, the green LED on the number 1 traffic light. You'll see why in a moment, but this is just for startup. So I put it in the setup function because I only needed to run it once when we first started up. I then asked myself, okay, what is it exactly I want to do? Now think about what you need to do. If the number 1 traffic light is green, that means the other light needs to be red. Well, the red on the other light was connected to pin 13. So, boom, I just set pin 13 to high. The red LED is now on. I then wait 5 seconds. Now in real life, the light probably stays green for like 20 or 30 seconds, but I'm in a hurry. This is only a demonstration, so I delayed 5 seconds. Now, what happens next? In Canada and the US, the green light then switches to a yellow for a few seconds, then to a red. I did that by first turning off the green LED and immediately turning on the yellow LED. I then waited 1 second. Now again, that's way faster than real life traffic lights. That would probably be more like 5 seconds, depending on the speed the traffic is going, but I went with 1 second. I then turned the yellow LED off and immediately turned on the red LED. There's no delay in between them. I then waited a second. Why? Because if you'll notice, cars at the traffic lights, when they're waiting at a red light, the drivers are like trying to jump the green light when they see the other light turning red. At the same time, the drivers which had a green light, now it's yellow, they're flooring the gas, trying to get through the intersection before it turns red. So if the other light turned green right away, well, those people floor the gas to get through the intersection just as the light turns green, and just as the last guy has floored it to get through the intersection just as his light turns red. Wham! You get a crash. So I threw in a 1 second delay between when the first light turns red and the second light turns green. Once that 1 second delay is over, we now turn this light green, wait 5 seconds before we go through the sequence of yellow, red, and then turn the other light green. I literally copied and pasted all these lines from the original Blink program, added them up, and just altered the numbers. I altered which pins turned on or off, and altered the delay. Easy peasy. Now I want to emphasize that there is almost always different ways you can do the same job. Most likely you either wound up doing the same thing or something similar, partly because you don't yet know the code and techniques to do it any other way. If you ran into trouble, did you forget to set up the modes for the pins? Did you mix up the pin numbers? Or did you do like I did and sent a high instead of a low to a pin? Did you forget a semicolon at the end of one of your lines? So these are all common mistakes. Now, before I move on, I want to point out something going on behind the scenes here that has made programming so much easier. Now, while programming in machine code, I personally feel it's important in learning about digital systems. Now, I understand machine code is a bear to wrestle with, and I truly hope that I did not, misjudge and make things too complicated for you to start off with. Now, I could have just started off with the Arduino, and things would be far more simpler, but you wouldn't understand the inner workings of microprocessors and microcontrollers like you now have. Now, you'll remember how the timing could be a critical issue in microprocessors and digital circuits. You learned that microprocessors could be so fast that it can literally count the bounces when you push a button. You learned that we had to slow the microprocessor down. And we did that by sending the microprocessor to, go run laps, basically. We would send it to go and just sit there and count a few million times. And even then, it was so fast, counting up into the thousands would only delay it like 1/100th of a second. And you remember all of the complex code involved in having it count down so many times. You'll remember how we did our utility delays. The Arduino's clock cannot be changed. It is locked in with a crystal, physically soldered to the board. Now that has some disadvantages. For example, you recall when we were using our LCD display, we cheated and just simply slowed the clock speed down on the PIC because the LCD took time to perform its duties. Now, we can no longer slow the clock speed down on the Arduino. So in order to keep our Arduino compatible with our LCD display, we now have to program delays into our code. So having a permanently set clock has some disadvantages. It does have a couple of big advantages. We now know exactly how long the microcontroller will take to count its delays. So remembering that your code here is translated into machine code. Similar to what we did on the PIC, but the writers of the Arduino compiler carried out a whole mess of long, hard work to make your life very, very simple. They now knew that to delay 1/1000th of a second, they had to have the Arduino count to exactly, 243 or something. I don't know what the actual number is, but they do because they did all the math. They calculated exactly how many clock cycles are consumed by how many instructions as the Arduino counts. And they can calculate with surprising accuracy what count they now need to make to delay 1/1000th of a second. So now you come along and type in one simple line of code, delay, and the time in milliseconds. The compiler then writes several lines of machine code to delay for 1 millisecond, and then compiles another loop to call that delay loop however many times you asked for it. If you asked for 500 milliseconds, the compiler wrote many lines of machine code for you, including writing multiple loops of loops, all to get that 500 millisecond delay. Now you remember that the PIC microprocessor was so fast, we had to get it to count to 256 times, and then to get even longer delays, we had to call that loop of loops another 256 times. You remember all of that? Well, look here. Some kind soul took the time to write a compiler to do all of that hard work for you, so all you have to do now is write one line of simple code, a delay line, and then tell it exactly how long you want it to delay. The compiler does the rest. In all of our previous exercises, the timing wasn't that critical. We just had to be slower than, some set time. But now we can be very precise and very easily. You can tell that microprocessor, hey, wait 16 milliseconds. Not 1 millisecond more or less. And it will. So these are some of the things going on in the background that you don't see, which I'm certain you now have an appreciation for as to what all they have done, because you have written machine code delays. All right, so if you didn't get your traffic lights working, you can fight with that now. Hopefully you figured out where you went off the rails, if you did. If it's still not working and you can't figure it out, please leave a question and your code in the comments, and we'll see if we can't help you to troubleshoot. If you want another challenge, make a light sequencer, like our kit car light that we did before with the pick, the like going back and forth. When we come back to the next lesson, we'll move on to inputs.